Hello guys, once again welcome to our YouTube channel Edu Hub, and as you know, this part 6 and this last part of our data analysis course. After this part the full course has been completed, so without wasting time let's get started. And guys, also comment which type of course you want, so let's start it. Data Analysis Part 6.
Welcome back. So since you're taking this course on advanced business intelligence features of Microsoft Excel, I'm assuming that you know the basics of Excel pivot tables. Things like pivot table construction and layout, grand totals and subtotals, built-in pivot table styles, slicers, and so on. If not, please refer to the optional Pivot Tables 101 section earlier in the course. Now, all that is to say, in this video, we're going to discuss some pro tips for customizing the look and feel of your pivots, beyond just the fundamentals and most common use cases. Let's get started. So here in our example file, we have a pivot table that has year, month, and date on rows, product category on columns, and revenue on values. Now, looking at this pivot table, you might notice that certain cells are blank. And while that's not necessarily a bad thing, for the sake of user-friendliness, it's often a good idea to replace these blank values with something more descriptive. So for example, in cases where our measure simply did not have any results for a particular set of coordinates in the pivot table, let's say, for example, there were no beach supplies sold on July 14th, 2018, instead of just having a blank, we could instead show $0, reflecting that we had no revenue for beach supplies on that date, or we could return some kind of message like no items sold. So let's see how we can do that in a pivot table. So first, I'll just click anywhere inside the pivot table to select it, and then right-click and choose Pivot Table Options. And under the Layout and Format tab of the Pivot Table Options dialog box, we'll see that there is an option to enter a custom value for empty cells. So let's say we wanted to return the message, no items sold, in place of these empty cells. Let's just type that, and then click OK. And there we are. Now it's a bit clearer to an end user who may not be terribly sophisticated with Excel exactly what's going on at those coordinates in the pivot table where no items in that particular category were sold. Now again, if you don't like this particular message, or if you'd rather return a number than a message, you could just as easily return 0 as your alternate result. Now, one thing to keep in mind as you're building reports to present to a potentially non-technical audience is that you should expend as much of your screen real estate, so to speak, on meaningful things that contribute to the message that your report is trying to convey, and as little screen real estate as possible on anything that does not contribute to that. So if there are components of your report that are really just taking up space and not contributing to your user's understanding of the data, it's probably in our best interest to get rid of them. So looking at our example pivot table here, we see one cell containing the phrase column labels with a filter button, and then another cell containing the phrase row labels. Now, I would argue that it's fairly self-explanatory what our row labels and column labels are doing, so unless you think a user is going to need those filter buttons and want to actively filter on the individual data points within the columns we used in our rows and columns, it's probably best to just get rid of those altogether. So to do that, we'll again right-click the pivot, choose Pivot Table Options, and now we'll click the Display tab in the Pivot Table Options dialog box. And to get rid of those unnecessary captions, we'll uncheck Display Field Captions and Filter dropdowns, and then click OK. And now, as you can see, our pivot is much cleaner. Those two somewhat confusing labels are gone, and the report looks cleaner and more professional as a result. Now, sometimes, as we're laying our pivot tables out, we want to customize the width of certain columns within our pivot table. Let's say, for example, for the sake of readability, we wanted to make all the columns in our pivot table just a little bit wider. So I can highlight all of these and then just resize one of them, and then all of them will be resized to that width. But what happens if I refresh the data source of the pivot table now? So we'll go to our Data tab and then refresh. And we see that by default, the width of our columns automatically adjusted to just barely accommodate the data within those columns. Now, sometimes this is helpful behavior, and if you've used Excel for any length of time, you've probably used the autofit feature to fit column widths to their data. But again, we're building a report for consumption by a wide audience. We may want to customize the look and feel of our pivot tables to a very specific level and not want our design decisions to be overridden by this default. So if we want those column widths to remain at the exact levels that we set them, we'll again have to go into our pivot table options to configure those defaults. So we'll right-click, Pivot Table Options, and now what we'll do is uncheck Auto Fit Column Widths on Update, and then click OK. And now we'll widen out our columns again, and then refresh. And as you can see, after the refresh is completed, our column widths remain the same. Now, one thing I'll point out is that while our column names here are similar in length, beach supplies, riding supplies, and surfing products all have roughly the same number of characters. This option becomes especially important if you have columns whose names are of significantly different length, because now the autofit will cause one column to be very narrow and another column to be very wide, which very often isn't the kind of professional look and feel that you want for a report that you're potentially submitting to a wide audience. Now, if you're familiar with pivot table layouts, you probably recognize that by default, this pivot table is using the compact layout. And that basically means that all the fields we use as row labels are collapsed into a single column. So you know that we have year, month, and date all on rows, but these fields are all contained within column B. The values in each field are simply positioned under the values in the field that's the next level up in the hierarchy. Now, most of the time, this compact layout is the most readable and user-friendly. But sometimes we need the fields that we have on rows to each have their own columns, and we need the values in those fields to be repeated for every row and every subgroup, essentially mirroring how the data would be organized in an Excel table or a database. Now, later on, we'll encounter a specific scenario where this is the case. So to do this, we'll first convert our pivot table to a tabular layout. So I'll go to my Design tab, and then Report Layout, and then Show in Tabular Form. And as you can see, each of the fields we have on rows now gets its own column. That's basically what tabular view is all about. Now, the next step is to go back to Report Layout and select Repeat All Item Labels. And now the data in our pivot is more or less organized like a standard table. And I can even get the column headers for these individual columns back if I go back into my options, and then the Display tab, and then recheck that Display Field Captions and Filter dropdowns field. So now we have a pivot table that is still very much functionally a pivot table, but also has the layout of a standard Excel table or even a table in a database. And again, as we'll see later, sometimes this layout can be exactly what we need for certain specific purposes. All right. Up next, we're going to look at another method for customizing the appearance of our pivot tables, one which majorly enhances our ability to tell a story with our data: conditional formatting. I'll see you then. Welcome back. So before we dive into the somewhat splashier topic of charts, let's explore a more straightforward, yet often equally effective, visualization tool for helping us better understand our data: conditional formatting. Conditional formatting, as the name implies, allows us to apply different formatting to different cells of our pivot table, depending on the values they contain. While we can make the custom formatting applied to pivot table cells as specific as we want, and based on as many logical conditions as we want, for starters, we'll look at some conditional formatting options that come more or less pre-packaged and ready to use. First up is data bars. So data bars are terrific for giving scale to a particular measure's numbers in a pivot. The largest number gets the biggest bar, the smallest number gets the smallest bar. You get the idea. Now, you may already be familiar with data bars if you've done a lot of work with Excel in the past, but adding them to pivot tables works just a bit differently than with standard Excel ranges. Let's see how. So here in our example file, we have a simple pivot table with state on rows and order count on values. So let's say we want to add some sense of scale and proportionality to the values in our order count column, so we can easily identify the states that had the most orders. So data bars are a great way to do that. To use them, we'll first select any cell in our order count column, and then on the Home tab of the Excel ribbon, we'll click the Conditional Formatting button, and then hover over Data Bars. And as you can see, we're given a number of pre-configured options for how those data bars might look. And if we just hover over those, we'll actually get a preview of what that data bar would look like applied to our selected cell. I personally prefer the gradient fills, and I'm partial to the color blue, so I'll select our blue data bar. And while this looks kind of pretty, it's not really doing a lot of useful work for us at the moment. The whole point here was to visually clarify where each value fits in relative to the others, but we've only highlighted a single cell. So to change that, let's click this little contextual icon that popped up right next to our cell that has our data bar. And now we'll see that we have the option to apply that formatting to just the selected cells, which is what we're doing now, or all cells showing order count values, or all cells showing order count values for name. Well, first let's try all cells showing order count values. Now this is kind of weird. We're getting a series of incredibly short bars for all of our states no matter how many orders they had. But if we scroll all the way to the bottom, we see the problem. Our biggest value by far is our grand total, which kind of makes sense. So compared to our grand total, even the total for a state that had lots of orders is going to look kind of puny, hence the small data bar associated with that state. So clearly we need to modify this once again. So to do that, we just click again any of the cells in our column that we're applying conditional formatting to, and then hit our conditional formatting button again, and then choose Manage Rules. And now we get a list of all the conditional formatting rules we've applied to this cell. Obviously, we've only done one thus far. So let's select this and then hit Edit. And now at the very top of this dialog box, we see those same three options for which cells we want to apply the rule to. And what we want to do is apply it to all cells showing an order count value for name. So obviously our grand total isn't broken out by the state name, but all these other cells are. So what we're really saying here is, don't include our grand total as one of the values that we're comparing to all the others. So now if we click OK, and then Apply, and then OK, now we see our data bars are working exactly as we would expect. States with a lot of orders, like New Jersey and New York, have very long data bars, whereas states with just a few orders, like Idaho, have a short data bar. Now you might be wondering how this sort of visualization would work in a slightly more complicated pivot table layout. Well, let's see. Let's add region as another layer to our row labels. So I'll scroll down to our regions table in my pivot table field list and then just drag in region name. And what we see here is that we have data bars for our state values, but we don't have them for our regions. So if we want to apply data bars to the regions level of our pivot table as well, first of all, we'll need to have subtotals in our pivot table so we have numbers to compare against each other. So I'll go to the Design Contextual tab for our pivot, and then go under Subtotals, and then select Show All Subtotals at Top of Group. So now we actually have numbers that we can compare to the numbers for the other regions. Then, to actually put data bars on these numbers, we'll need to select one of them that is directly adjacent to a row label for region and not state. So I'll choose cell C2 here that has our number for the East North Central region. And then I'll just follow the familiar steps. Go to our Home tab, Conditional Formatting, Data Bars, and perhaps to offset the visualization for region versus state, I'll use a slightly different color, maybe red. So I'll choose that, and then I'll click our little button here and apply our formatting to all cells showing order count values for name, where name in this case is region name and not state name. And now, just like we had for state, we get a visual sense of scale for the order counts for all of our respective regions. Pretty cool. Now sometimes, instead of simply applying scale to the numbers in our pivot, we want to assign additional meaning to each number by slotting it in on a continuum somewhere between good and bad. Two effective ways of going about this are color scales and icon sets. Let's take a look at color scales first. So color scales use color to call out where the numbers in our pivot tables fit in on a scale from bad to good. Now this requires us to define a good color and a bad color, as well as defining precisely what good versus bad even is. For example, sometimes a bigger number may be good, as with revenue or profit, but it may also be bad, like with customer calls abandoned. Now this may sound like a lot of work, but fortunately Excel makes it easy. Now first, just so we have a different metric to apply our conditional formatting to, I'll create a whole new measure called orders within SLA percentage. And this will basically just say, for any given set of coordinates in our pivot table, what percentage of orders were shipped within our SLA. So real quick, I'll go to our Power Pivot tab, Measures, New Measure. I'll assign to the Orders table, and I'll call our measure again, Orders percent within SLA. And then our measure is going to be super simple. It's just going to be the average of our within SLA field in our orders table. And then we're going to format that as a percentage. And then we'll click OK. And now we have our new measure in our pivot. So now to apply color scales to our new measure, I'll just make sure I've got any cell in that column with our measure selected, and then again hit our conditional formatting button. And now I'll hover over the color scales option, which again allows us to preview a series of different color palettes. So since our measure is one that would be considered to be performing better if it's a bigger number and worse if it's a smaller number, it makes sense to choose a color scale where there's a color associated with negative performance at the lower end and better performance at the higher end. Now in the analytics world, quite commonly warm colors, especially reds, are associated with negative performance, and cool colors, especially greens, are associated with positive performance. So I think I'll select this very first one, and then click this button so we can make sure our conditional formatting rule is applied to all cells at this level of hierarchy in our pivot, that being region, other than the grand total. So I'll say all cells showing orders percent with an SLA values for name. And now as we scroll down, we see that our very low percent with an SLA for East North Central is colored red, and most of our other values are yellow, but our very highest values are either green or a shade of green. And then we can do the same operation for the state level of hierarchy in our pivot. So we'll select one of those cells, and then color scales, and we'll pick that very first scale, and then we'll make sure that's applied to all the states. And again, scrolling down, we'll see that the states that performed best, that had the highest SLA, get the greenest color, and the states that performed worst get the reddest color, and all the other states are somewhere in between. Now sometimes, a simple scale doesn't provide enough nuance to call out important aspects of our data. It's often the case that our metrics have important thresholds or cutoff points, above or below which their performance is considered to be significantly better or worse. For example, let's say that for our within SLA percentage metric here, anything 90% and above is considered good, anything 75% and above is considered acceptable, and anything less than 75% is considered poor. In a case like this, the thresholds are very important, but we don't care all that much about how numbers vary between the thresholds. For situations like this, icon sets are the smart play. So let me show you how we can use them to add a little more meaning to our within SLA percentage metric. So the first step is to edit our existing conditional formatting rule for percent with an SLA. So I'll hit our conditional formatting button and then choose Manage Rules. And you can see that we actually have two rules with color scales because we're applying those rules to different levels of hierarchy within our pivot. So I'll select the one for states first and choose Edit. And now at the bottom of the dialog box, you can see that we're currently applying a 3-color scale conditional format. So to change that to an icon set, I just click this drop down and choose Icon Sets. And now we get a whole different set of options. First of all, we can choose different styles of icons to use. So right now we have essentially traffic lights as our icons. But if we click this drop down, we see that we can employ flags, a different style of traffic light, or one of my personal favorites, a red X, a yellow exclamation mark or warning sign, and a green check mark. So I think I'll actually opt for that one. And now below that, we get to specify the exact thresholds at which we use each of these icons. So again, instead of showing a potentially infinite number of shades of color depending on our numbers, each value in our column is going to get one of these 3 icons depending on where that value fits in on the ranges that we specify. So going back to our original specifications, we consider 90% and above to be good performance. So when our value here is greater than or equal to 90, we want to return this green check mark. Now, one thing I'll caution you against here when using icon sets is using a type of percent, even if your measure is a percentage. I have found that particular feature to be buggy and unreliable, so I'd say instead use number, and then for your value, just use the actual numerical value of that percentage, which in the case of 90% is just 0.9. And now for our next threshold, if our value is 75% or 0.75 or above, then we want to return that warning sign, that yellow exclamation mark. So first we'll change the type to number, and then change that number to 0.75. So now, by default, when that number is not greater than or equal to 75%, we want to return this red X. So this looks like it should be good to go, so we'll click OK. And then we'll hit Apply. And just a brief scan of the cells in that percent with an SLA column shows that it appears our conditional formatting is working. But before we click out of this dialog box, I'll also change the conditional formatting rule we've applied to region in our pivot and pretty much do it the same way. We'll go for icon set, and we'll change that to our X exclamation mark and check mark. And then for our thresholds, we'll choose 0.9 and 0.75, and then click OK and Apply. And now we can click OK again. And now rolling down, we see that we have, honestly, precious few good performing states, quite a few middling ones, and just a handful of bad ones. But the bigger picture is our conditional formatting rule is working exactly as we intended. All right. Now that we've seen how much we can accomplish with the pre-packaged conditional formatting options Excel gives us, it's time to learn how to create our own custom conditional formats and conditional formatting criteria to give us even more control over the story we tell with our data. That's up next. I'll see you then. Welcome back. So much of the time, canned conditional formats, like the ones we saw in the last video, are all we need to add that extra level of meaning to our data. But there are also times when we need a custom solution, that Excel's pre-configured solutions just don't have an answer for. The good news is, we are totally free to roll our own conditional formats and conditional formatting criteria. So let's walk through a couple of examples where this might be useful. For starters, let's say we just want to flag any cells with an SLA less than 75% in our pivot table here, point blank period. Otherwise, we don't want to apply any additional formatting. So to do this, I'll select any cell adjacent to one of our states, and then hit our conditional formatting button, and then hover over our Highlight Cells Rules option in our conditional formatting dropdown. Now, because we're highlighting a number, we get 4 options here specific to numbers: greater than, less than, between, or equal to. Now, we want to call out values that are less than 75%, so we'll choose that option. And now for our value, we'll enter 0.75, and we'll go with Excel's default recommendation of light red fill with dark red text. So then I'll click OK. And we don't see anything happen because our particular selected cell is not under 75%. But let's click our little contextual button here and then apply our rule to all cells in this column other than the grand total. And now scrolling down through our pivot, it looks like all of those cells with an SLA less than 75% have in fact been called out. And then real quick, we can do the same thing for the region level of our pivot. So again, highlight cells rules, less than 0.75. And then we'll modify that to look at all of our labels and not just the selected one. And looking at our various subtotals, that appears to have worked as well because the one subtotal under 75% has been highlighted. Now let's say, for example, we're not totally satisfied with the color format that Excel chose for us. We can always go back into our rule and edit these formats if we so choose. So I can again hit our conditional formatting button, choose Manage Rules, and then I'll just select one here to edit it. And I'll point out before we move on that we're again taken to this same Edit Formatting Rule dialog box that we've already seen multiple times. So at this point, you're probably realizing that all of these shortcuts you see from the conditional formatting button on the ribbon really just take you to different configurations of this exact same Edit Formatting Rule dialog box. So in this particular case, what we're doing is editing the formatting that's being applied. So we'll click this Format button at the very bottom. And I think I'll leave the fill color the same, but I'll change the font color to simply be black. And then click OK. And then I'll do the same thing for our second rule. And then click OK again, and then apply. And now we see that our formatting is still applied, but the font color is now the default of black. Now, the conditional formatting we've applied thus far is arguably not all that interesting. But now let's add a little bit of nuance. Let's say that while any low SLAs are bad, we especially care about them when they're tied to a state or region that has had lots of calls. Say at least 1,000. But now we're applying formatting based on values in a different column. So we want to apply our conditional format to our orders with an SLA measure, but based in part on the value in a completely different column. There's no single click of a button that can help us here. We'll actually need to use a formula as our criteria. So let's see how that works. So the first step, as usual, is to select a cell in our measure column and then hit the conditional formatting button. And now, because the rule we're applying is sufficiently complex, we can't use any of these shortcuts. So instead, we'll just select New Rule. And that takes us back to this familiar dialog box. And now, as I mentioned, we're going to use a formula to determine our conditional format, so we'll select that option. And just thinking through our logic, what we really want here is to apply our format if the value in our orders with an SLA column is less than 0.75 and the value in our order count column is greater than 1,000. So to apply multiple criteria where all of them need to be true, we can simply use the AND function. So we'll type equals and then we'll just select cells in our pivot table to build out the criteria. So first we'll select D4 here and say less than 0.75. And then our second criteria will be that C4 is greater than 1,000. And now for our format, I think I'll make the cell font that dark red that we saw earlier. So I'll change our format to that and click OK. And then before we exit our formatting rule dialog box, I'll make sure that I'm applying this rule to all cells within this particular level of hierarchy in our pivot. And then I'll click OK. And scrolling down through our pivot, even for an example like New Jersey, where there were more than 1,000 orders and our SLA is less than 75%, we don't see our new font formatting. So let's go back into the rule. So we'll choose Manage Rules, and then edit our rule. And now if we look at the formula for our conditional formatting rule, we see the problem. The cell references in our formula are absolute, as denoted by the dollar signs before both the column and row reference. Because of this, our rule is only being applied to cell D4 out of all the cells in our orders within SLA column. So to fix this, all I have to do is remove the dollar signs from these cell references so that the references are relative and apply to all the cells in our column equally. So now I'll click OK and then Apply. And lo and behold, if we look at our row for New Jersey, which again meets our additional criteria, we now see that dark red font color applied. So now we've basically got two different layers of rules in play. One that applies to all cells where our percent with an SLA is less than 75%. And then a second one that only kicks in if that first condition is true and our order count is greater than 1,000. So even though we didn't specify both pieces of logic in both rules, both formatting rules are applying to our cell for New Jersey here. Now that happy state of affairs will not always be the case. So if I go back into our rules and then switch the order of our rules, so let's say I move this rule that we most recently created to the bottom by clicking this down arrow here, and then click Apply, suddenly our special formatting for New Jersey disappears. So what's happening here is, if there is some level of conflict between the formatting applied by our different rules to the same cell, whatever formatting is applied by a rule that comes first wins. So our first two formats say, apply a font color of black. And then our last rule says, apply a font color of dark red. Well, if we're in a cell where both of these rules apply, the formatting of the rule that comes first in this list wins. So what this should tell you is that more specific criteria, like the one that we just built based on a formula, should generally come first, and broader criteria should come later. So if I move our new rule, our formula-based rule, back to the top and then click Apply, our formatting for New Jersey reappears. Again, that's because our font color for that particular rule is winning out, even though the conditions for another rule are also met for that particular cell. Now, if you want to play it safe and keep the various styles you're applying mutually exclusive, such that only one set of styles is ever applied, you can use this Stop If True option over here on the right. So that basically says, if all of these conditions for a particular rule are true, don't bother trying to apply any formatting from any other rules. The trick here would be to make sure that each set of conditions is comprehensive and mutually exclusive. Alright. Now, while conditional formatting is a straightforward and highly effective way to add a data visualization component to your pivot tables, we've yet to explore Excel's most powerful technique for guiding your end users to insights about their data: charts. We'll begin our exploration of charts in the next video. I'll see you then. Hey, welcome back. So conditional formatting has shown us how adding some visual effects to our data can help us gain insights and draw attention to relevant values. But sometimes the raw data itself isn't the best mechanism for conveying these insights or understanding. Computers are great at processing large tables of numbers quickly, but human beings aren't computers, and sometimes the meaning of our data gets lost amid a forest of individual data points. You know the saying, a picture is worth 1,000 words? Sometimes a picture can also be worth 1,000 data points. And that's where charts come in. Charts are basically visual representations of data that are separate from the data itself. A good chart should tell a story about the data it is based on that provides summary and insight that a human being can easily grasp and use to make decisions. Excel has extremely powerful charting capabilities and a wide variety of charts that we can use to visually describe our data. However, there are a handful that are used more often than others, so we're going to focus on those. So without further ado, let's paint a picture of some data with a little help from Excel. Now, this being a course focused on business intelligence, we're going to make use of a special kind of chart called a pivot chart, which is constructed in much the same way as a pivot table, and has all the same advantages in terms of being dynamic, as well as being connected to our data model, and thus able to potentially summarize millions of rows of data. We can construct a pivot chart as a standalone entity, or build a pivot table first, and then create a pivot chart based on that. While for many purposes you may not want or need the pivot table alongside your pivot chart, for starters, it's a good idea to start with just a pivot table to clarify your thoughts on exactly what data you're trying to visualize. So with all that said, let's start our charting adventures with a simple pivot table with region on rows and order SLA percentage on values. So I'll go to Insert, Pivot Table, and then I'll put region on rows, and then our new orders with an SLA metric on values. And now that we've got our pivot table in place, let's see how we can visualize the data within it with a pivot chart. So over on the right side of our Pivot Table Analyze Contextual tab on the ribbon, you see this Pivot Chart button. So if I click that, now Excel gives us a long list of charts that we can apply to the data in our pivot. For starters, I'm going to choose a chart called a bar chart. So I'll select that, and now we actually get a little preview of what our data will look like, visualized with a bar chart, and then we'll click OK. And now just to see this a little more clearly, I'll get rid of my field list, drag it over, and then widen it out just a bit. And as you can see, the layout of the bar chart is fairly straightforward. Regions with a higher SLA percentage get a larger bar, whereas regions with a smaller SLA percentage get a smaller bar. In this sense, bar charts work a lot like the data bars we had applied to our pivot tables previously with conditional formatting. Now I chose a bar chart intentionally for the data that we're laying out in this particular pivot table because bar charts tend to be good at helping us visualize a comparison between different items, which is basically what we're doing here. So briefly, I'd like to recap the components of this chart, which are similar to the components of any chart that we'll see. First is the data series. This is the actual visualization in the pivot table. For a bar chart, that's these bars that you see. For other charts, it might be a different type of visualization. But the bottom line is, it's the visual component that represents the numbers that you're plotting in the chart. Up next is the category axis, which breaks out whatever metric it is that we're visualizing by the items within a certain field. In our case, that field being our region field. Then going horizontally across the bottom of the chart is the axis that gives scale to the actual measure that we're plotting in the pivot chart. This lets us know how tall a tall bar actually is. And we see that the tallest, or I guess it would be more accurate to say widest, bar in our bar chart here is for the West North Central region, which is all the way out at 100%. Further, all the way over at the right where you see the word total is the legend of our chart, which you'll see the value for later, but with a simple chart like this just doesn't have a lot of utility. And then at the very top, where you also see the word total, is the title of our chart. Now obviously a chart title consisting of the word total isn't terribly useful either, but fortunately, like with almost every part of a chart, we can customize this to make it work for us. Finally, pivot charts come equipped with filters that allow us to filter the categories whose performances we're visualizing in the chart. So if I click this Name Filter button, I can actually selectively filter for just certain regions that I might want to see in our pivot chart. Now, to be honest, this is often not a terribly useful feature, and as we'll see later, it's something that you can get rid of to make more room for the other elements of your chart. But for now, I'll undo those filters. And now that we've seen the basic components of a chart, let's take a look at modifying one. So our horizontal axis at the bottom of our pivot chart goes out to 120%. But that really doesn't make a lot of sense because our orders with an SLA measure could only ever go as high as 100%. So if we want to change the scale of that axis, we first click it to select it, and then right-click and choose Format Axis. And now if we look at the Bounds section, we'll see the minimum is 0 and the maximum is 1.2. But what really makes sense is for the maximum to just be 1. So let's change that, and then close out of this. And now you'll see that our axis has a much more sensible range from 0 to 100%. Also, I'm going to change this sort of nonsensical title here to read Order SLA by Region. Now another way you can customize your pivot charts is to apply one of a really large number of pre-configured formats that Excel gives you for your charts. Now with our chart selected, Excel brings up several new contextual tabs on our ribbon. The one we're on now is Format. There's also the Pivot Chart Analyze tab, which lets us change the fundamental construction of our pivot chart in much the same way you would a pivot table. And then there's the Design tab, which includes these pre-configured chart styles. So if I click this button at the bottom right of that list of styles, I can now hover over them just to get a preview of the various types of styles I can apply to my chart with a single click. Now for now, I'll leave it at this somewhat vanilla default style, but again, depending on your personal tastes and the tastes of your audience, you could go with a much flashier style with a lot more pizzazz like this, or if you're a boring guy like me, you can just stick with the plain vanilla default. It's entirely up to you. Now when dealing with pivot charts, it's worth noting that Excel will try to convert almost any pivot table to a pivot chart, but for complicated pivot tables, this usually won't go well. As such, until you get a good intuition for creating pivot charts, it's best that you be very intentional about what fields you add and create your pivot table with the chart in mind, not with the chart as an afterthought. So just as an example here, let's add state as an additional layer to our pivot table. So I'll go back into my pivot table Analyze tab, and then our field list, and then I'll go down to my states table and drag in state below region. And now if we look back at our pivot chart, it is dutifully attempting to visualize the hierarchy in our pivot table, but not doing a particularly great job of this. In fact, this pivot chart is what folks of the younger generation would probably refer to as a hot mess. So because this is giving me a headache already, I think I'm going to go ahead and remove state from our pivot table. And now we're back to a more sensible layout for our pivot chart. So now that we have some intuition for how pivot charts work, let's try our hand at creating one from scratch without an underlying pivot table. So first, let's go ahead and delete this chart, and then I'll even delete the underlying pivot table as well. And now I'll recreate the view that we just saw, but only using a pivot chart without bothering with that underlying pivot table. So I'll go to my Insert tab, And now instead of hitting the pivot table button, I'll hit the pivot chart button. And you see that we have the option to either create a pivot chart or a combined pivot chart and pivot table. But the second option would be pretty much what we just did in our last example. So we'll choose pivot chart, and we'll create it from our data model just like we always do our pivot tables. And now Excel is telling us to turn on the pivot chart field list to work with the pivot chart. And the field list for pivot charts works almost exactly like the field list for pivot tables. So we'll click this field list button on the pivot chart analyze tab. And now we're able to drag fields into these different squares just like when we're constructing a pivot table. First, we'll drag in our measure into the values area. So we'll go to our orders table and drag in orders with an SLA. And you see that with nothing to break this measure out by, we just get one tall column representing that measure for all categories not broken out by any particular thing. Next, to break this out by region, I'll drag the name field from our regions table into the categories axis. That's always going to be the component of our pivot table that breaks out the single bar that you see by the values in that field. So for our regions field, instead of seeing a single bar, we'll see a different bar for each individual region in our data. And now finally, because we're not seeing a bar chart here and we're trying to recreate our original view, with this chart selected, I'll go to the Design Contextual tab, and then I'll hit this Change Chart Type button. And this takes us to the dialog box we saw originally, which lets us select what type of chart we want to use to visualize our data. So I'll choose bar, and then OK. And then I can quickly make the formatting adjustments that I made previously. I'll widen our chart out. I'll fix the scale of the axis. I'll change the title. And there we have it. We have the same visualization we had before, but without the clutter of that underlying pivot table, which is important if all we're interested in is the high-level visualization without seeing the numbers behind it. Now, a major advantage of pivot charts is our ability to control them with slicers, which are just as effective and user-friendly a tool for applying filters to pivot charts as they are for pivot tables. So let's say I want to be able to slice and dice this pivot chart by whether or not the customers for these orders were loyalty club members. So with our pivot chart selected, I'll go to the Pivot Chart Analyze tab and then hit Insert Slicer. And then on that dialog box, so I can access tables that are not among the tables that are in our pivot, I'll hit the All tab as opposed to the Active tab. And then I'll go to our Customers table and choose Loyalty Club Member, and then OK. And now we have a slicer that again will let us filter our values for whether or not a customer is a Loyalty Club member. So I'll drag this out of the way of our pivot and then shorten it up a bit and also widen it out a bit. And now I can control the underlying data of our chart simply by selecting different values in our Loyalty Club member slicer. Now it's worth noting that as with pivot tables, you can actually control multiple pivot charts with a single slicer, or have multiple slicers that each control multiple pivot charts. This gives you the ability to create dynamic reporting and dynamic dashboards with ease. Now, we briefly saw earlier a glimpse of another type of chart when we first created this pivot chart from scratch. So let's explore that a little bit more and convert our bar chart here back to that particular kind of chart. So with our pivot chart selected, I'll go back to our Design tab and then Change Chart Type, and then I'll go back to the type of chart we saw before, which was a column chart, and then click OK. Now, while for the purposes of the simple visualization we're doing here, our column chart really isn't accomplishing anything our bar chart wasn't, column charts are also more versatile than bar charts. To that, up next, we're going to continue our exploration of pivot charts in general and column charts in particular by incorporating a time component into our visualizations. I'll see you then. Welcome back. So in the last video, we saw how column charts can be used to visualize comparisons between data points. But they're also highly effective at visualizing how numbers change over time. Say, for example, we wanted to compare sales of our different product categories over time, as we see here. With pivot charts, it's surprisingly easy. So let's get started. First up, in our starter file, let's go ahead and create a pivot chart with year and month on rows and our number of line items sold measure on values. So I'll go to Insert, Pivot Chart, and then I'll just create a pivot chart, not a pivot chart and a pivot table. And then for our measure, I'll go to our Order Details table and drag in our number of line items measure. And then for my category axis, I'll go up to our calendar table and drag in year and then month. Now this breakout is fine as it is, but to me, the inclusion of months has made our chart just a little bit too granular. Unless we want to make our chart really, really wide, like as wide as our entire screen, we just don't have the screen real estate to see all of the months for all of the years over the entire time frame we've been selling products. So quarter might actually be a more appropriate breakout under year. So let's try that instead. So let's remove month and then drag in quarter. And already that just looks a lot cleaner and easier to interpret. And because we're dealing with a slightly less granular breakout of our time frame, now we're able to see all the individual quarters above their respective years. So now we've introduced the element of change over time into our visualization. But what if we want to compare how our value changes over time among different categories? So right now we're just looking at how our number of line items sold measure overall changes from one year, from one quarter to the next. But what if we wanted to see a breakout along, say, product category? How can we show a comparison between the numbers for each of these categories while also retaining this quarter over quarter, year over year trending we have right now? Well, it turns out that's what this legend section of our field list is for, if we need to see our measure broken out by multiple different categories. So let's add product category to that section. And now for the first time, this little section over to the right of our chart is starting to make sense. Whereas before, when it simply said total, it clearly wasn't adding much value. Now it's providing us this useful color-coded breakout of the three categories that we're plotting for every quarter in our chart. So instead of it just being useless chart junk that we would delete to free up more space in our chart, it's something that's not only useful, but quite essential to interpreting the dense information that we've managed to cram into this one chart. Now, if we want to supercharge our chart even further and give our users even more ability to slice and dice the data being visualized in different ways, we can again add a slicer. So to create some room, I'll get rid of our field list here and then drag our chart over to the left. And now, with the chart still selected, I'll choose Insert Slicer and then click the All tab and then find our Regions table and insert a slicer for that. And now, since we have quite a few regions, I'll change the orientation of our slicer to have 3 columns instead of 1. And then I'll widen it out just a bit and just a bit more, and then shorten it up a little bit. Then I'll change the caption to read region. And now I'll drag this over just a bit to kind of align it with our chart. And now that we have our slicer, we can use it to interact with our chart and see what our trending looks like for just one particular region at a time. Or if we configure our slicer to allow us to select multiple values, we can see how our numbers look for multiple regions at one time. Now, before we go, I want to introduce you to a different variation of a column chart that's particularly useful for visualizing how the different categories in our chart add up as percentages of a whole. So let's make sure our chart is selected, and then hit the Design Contextual tab, and then change our chart type. And now, with the column chart category still selected, we're going to select the second option from the left, called a stacked column chart. And now if we click OK, you see that instead of a different column for each of our categories, all of our categories are condensed into a single column. And within that column, we see the relative proportion of each category. So in this way, it's more effective than a traditional column chart in conveying how much each of our categories contributed to our measure for a given quarter. Okay, so up next, we're going to walk through yet another type of chart, this one even more effective at visualizing changes in our data over time. I'll see you then. Hey, welcome back. So we saw in the last video how column charts can be used to visualize trending. That is to say, how our metrics change over time. Well, there's another type of chart that arguably does this even better: line charts. So in this video, we'll learn to use line charts to visualize our measures changing over time. And while we're at it, we'll also explore a special kind of slicer that's purpose-built for working with dates. Let's get started. So before we go and convert this chart into another type of chart, I want to do just a little bit of cleanup on it first. So I mentioned in the last video that our little legend over here on the right side of the chart is no longer chart junk that just takes up space in the chart without doing anything meaningful. However, we still have these filter buttons all over our chart that are quite unlikely to be used by our end user, especially when we have the option of inserting slicers outside of the chart, which are more intuitive and user-friendly. So if we want to free up some space in our chart by getting rid of those, all we have to do is right-click one of those buttons, and then choose Hide All Field Buttons on Chart. And now they all disappear, and we have a more professional-looking chart that also has a little more breathing room for the stuff that actually matters, which is our data. Now, another step we could take here is to add a title to our chart, just to clarify what its purpose is. So to do that, I'd go to our Design Contextual tab, and then hit this Add Chart element over on the left, and then hover over Chart Title, and specify Above Chart. So now we've inserted a new object into our chart, that being a chart title, and with that object there, we can customize the text however we see fit. And so I think I'll call our chart Items Sold by Product Category. And now we have a nice, clean, professional chart whose purpose is clear and doesn't have any extraneous junk or noise to distract us from the message we're trying to convey. So with this chart as our starting point, let's convert it to a line chart to see the contrast in how the line chart conveys change over time. So I'll select the chart, and then go to my Design tab, change chart type, and then I'll choose Line Chart. And while you could certainly argue the column chart did accurately convey trending over time, the line chart does this a little more naturally by literally connecting the dots between each individual time frame on our chart, not only conveying what happened at a given point in time, but the overall trend of how things are changing over time, which is generally what we want to see in a chart that has a time component. Now, one feature you can add to a line chart that augments this capability is a trend line. So if I click one of these data series for one of our product categories, and then right-click and choose Add Trend Line, now I'm given a list of options for different trend lines that can automatically be drawn on our chart that basically smooth out the noise from individual data points into a visualization that captures the overall trend of our metric over this time frame. Now there's lots of different options, but many of these involve some level of statistical knowledge, and this is not a math or stats course, So I'll stick with the most common and default for now, which is linear. And then turning our attention to the chart, we see this nice little trend line that captures the overall big picture trend of our beach supplies sales from the very beginning of our time frame to the end. And obviously you could continue adding trend lines for the other product categories in our chart as well if you saw fit. So now that we've seen what line charts can do, in the same way as we looked at a variation of column charts called stacked column charts, let's look at a variation of line charts called stacked area charts. So if we go up to change chart type and then choose area, and then choose this second option from the left called stacked area and click OK, you'll see that we still get this nice sense of trending of our metric over time, but we also get a visualization of the proportionality of our different product categories to each other. So in short, a stacked area chart like this is great for conveying both trending and proportionality in your data. Now, one downside is they do not allow you to add trend lines in the way that you can with line charts. So if I select one series and try to add a trend line, you'll see that that option's grayed out. So that's just something to keep in mind as you're weighing whether to convert your chart to a line chart or a stacked area. So now that we have the right charting tool for the job of conveying trending over time, let's look at a specialized type of slicer that allows you to dynamically adjust the time frames reflected in your pivot tables and pivot charts. And that's called a timeline. Timelines are yet another feature that can give your Excel reports a dynamic dashboard style element. So let's see how they work in action. So I'll click our pivot chart here and then go to the Pivot Chart Analyze tab. And then right next to the Insert Slicer button, we'll click this Insert Timeline button. And then the field you're going to want to use as the basis for that timeline is generally going to be the date field from your calendar table. So we'll choose that and click OK. And then drag this over to be roughly parallel with our region slicer. And we see that our timeline very much has a slicer-like interface, such that a user who's familiar with using slicers and comfortable with that interface would also quickly become comfortable using a timeline. So one bit of value that timelines add to your pivot charts is that they give you incredibly fine-grained control over the time frames reflected in your pivot charts. Now this makes it feasible to include more granular breakouts of your measure. So remember before, we tried to add month to our chart, but it ended up just being a little bit too messy because there were so many different months included across the entire time frame we were looking at. But if we now select our chart and then swap out quarter for month, at first we're kind of back to square one. But now, using our timeline, we can select incredibly specific slices of time so that our new monthly breakout makes more sense. So first I'll click this drop down that currently says months and change that to years. And then I can actually just click to select any one of these years over which we have data. And if I select 2020, for example, now I have this nice clean breakout of monthly trending just for that year. Now, what if I wanted to select multiple years? You don't have to hold down Control or Shift and then click one year or the next. Actually, if you hover over the year that's selected, you'll see that you have a handle on either side of that selected year. And if you hover over that until your cursor changes into this little horizontal arrow, you can actually drag it to select another year. And of course, we're not limited to selecting for just years. We can also select quarters or months in just the same way. So if I uncheck all of our filters, I can now choose quarters in my drop-down box, and then perhaps start with a single quarter, perhaps the first quarter of 2020, and then I can just start dragging until I get perhaps to the fourth quarter of 2021. So you can see at this point how this timeline gives us complete and dynamic control over the time frame of the data displayed in our pivot chart, essentially giving you an infinite number of pivot charts in one. The ability to condense this many potentially different views into one single chart is what dynamic reports and dynamic dashboards are all about. Now, it's worth noting that you don't even have to have a time component in your pivot chart to use a timeline as a slicer. So for example, what if I just removed the date and time component from our chart altogether? So I'll go to my field list and just remove year and month. And now I'll drag product category down into my category axis, and maybe I'll convert my chart to a bar chart. So now I have an admittedly very simple chart, but nonetheless one whose data I can dynamically vary now in multiple different ways using my two slicers. I can not only select any combination of regions I want to filter this data, I can also vary the time frame reflected in the data to be as wide or narrow as I want. So just for example, if I switch back to years, I can choose 2019 through 2021, and you'll see that the lengths of the bars change. Or I can switch to months, and then just select a few very specific months. So maybe I only want to select maybe 6 months from January 2020 through June 2020. I'll just scroll back to my very first selected month and go all the way to January 2020. And then I'll go to the end and scroll back the other way. And now my chart reflects a different time frame. And if you look at the top left corner of the timeline, you'll see that we have a helpful little caption that summarizes the timeline we've selected. Now right now, since the 6 months I've selected reflect quarters 1 and 2 of 2020, that's how the caption summarizes it. But if I were to add one more month, now it instead says January through July 2020, because that is now the most efficient way at conveying that time frame. All right, so continuing the theme of packing as much information as possible in as small an area as possible while still making our interface user-friendly and our information easy to interpret. Up next, we'll look at another type of chart, or perhaps more accurately, type of charts, that can help us crunch even more value into our limited screen real estate. I'll see you then. Hey, welcome back. So right now, our pivot chart is breaking out our number of line items sold measure along multiple different dimensions, by product category as well as by date. But sometimes we want to plot two entirely different measures alongside each other in the same chart so we can compare their performance over time, or by some other dimension. Now, since I'm bringing this up, you've probably guessed that Excel has a solution, and you would be correct. So let's see how it works. So first up, I'm going to naively just add the profit measure to our pivot chart. So first I'll select our chart, and then click our Pivot Chart Analyze tab, and then activate the field list, and then I'll just drag in our profit measure on values. So now looking at our chart legend and the lines we see in the chart area, it's clear that one of our measures is drowning out the other. Our highest line by far is profit for surfing products, and then our second highest is profit for beach supplies. Our third highest is profit for riding supplies. And then all of the other lines are basically hugging the exact bottom of the chart. So why is it that our profit data series are drowning out our number of line items sold data series? Well, that's basically because all of these numbers are being plotted on the same scale, but our profit numbers are just intrinsically higher. For each line item sold, we're probably getting a profit of much greater than a single dollar. So for any given product category, our profit number is just inherently going to be quite a bit bigger than our line item sold measure. And as a result, with both of these measures plotted on the very same axis, our line item sold data series all end up getting squished all the way down to the bottom of the chart. Now, aside from that issue, the fact that our chart has 6 data series that we need to keep track of is also less than ideal. This is a good example of why, in general, if you're going to plot multiple measures on a single chart, it's a good idea to not break those measures out into multiple series, as we have here with product category. Otherwise, things get too crowded and muddled to easily understand. So our first step here is just going to be to remove product category from our legend section of our pivot chart. So now we have even more clarity into what's going on as far as our line item sold measure getting squished all the way down to the bottom of the chart. So how do we solve this issue? The solution, it turns out, is to create a secondary axis on the right side of our chart to plot our profits against. Now, one way to do this is to manually select the series that we want to plot on that secondary axis, which I can do just by clicking the line, and then right-click and choose Format Data Series. And now where by default the series is plotted on the primary axis, we'll choose to plot it on a secondary axis. And now if we close out of this window and reselect our chart, we see that both of our measures are now plotted according to a reasonable scale, which means that one is not able to drown out the other. Our profit measure is plotted on a scale ranging from $0 to about 1.2 million, whereas our number of line items sold measure is plotted on a scale from 0 to 16,000. Now the problem with this view is, it's not immediately obvious which series is which without referring to our legend and its color coding. And while this is okay, it's often a good idea to plot each measure with an entirely different kind of chart. In this case, for example, we could try a column chart with our profit measure. But to do this, we actually need to convert our overall chart type to something called a combo chart. So first, let's take our chart back to its original state by putting profit back on a primary axis. And now we're actually going to convert our chart type to combo. So we'll go to the Design tab, change chart type, and then all the way at the bottom, we see this combo chart option. And looking at the bottom of this window, we see that for each data series, for each measure that we're plotting, we have the ability to choose what type of chart we want that metric to be plotted as, and which axis we want it plotted on. So I'll choose a line chart for our line item sold, and then I'll choose a column chart for our profit measure, and I'll plot our profit measure on the secondary axis. And then click OK. And now finally, to make our chart title reflect what we're really displaying, I'll change that to Profit versus Items Sold. And now we have this nice condensed view that shows how not one, but two of our measures, whose numbers are on a completely different scale, change over time. All right. Up next, we'll look at an advanced application of slicers that lets us create dynamic dashboards in which we can use a single chart to toggle through as many measures as we want. I'll see you then. Welcome back. Now, in the last video, we ran up against the practical limitations of how much information you can cram into a single pivot chart before it starts to become unwieldy and hard to interpret. When we tried to plot multiple measures and multiple categories, there was quite a bit more going on in our little chart than our poor users could be expected to make any sense of. But dashboards are all about cramming lots of meaningful information into a small space, as long as that information can be easily understood and interpreted by our audience. So using this case as just one example, is there any way we can get all of this information in one chart while also making sure we don't give our end users a migraine? Well, it turns out there is. And that's by using a slicer to dynamically change the measure we display in the pivot. Now, since we're only plotting one measure at a time, we're free to break that measure out into multiple series, as we're doing here by category. So if you look at our measure slicer here at the bottom right now we've selected our line item sold measure. But then I can choose profit, And now our chart changes to reflect how profit changes over time, but also broken out by our 3 product categories. And of course, I can also choose revenue. And in each case, the axis of our chart dynamically changes to reflect the different scale of the measure we chose. Now, doing this takes a little bit of setup, as you might imagine, but the results are well worth it. So let's take a shot at building this from scratch. So our first step is to create a table that has a list of all the different measures that we're interested in toggling between. Now, an easy way to do this is to create the table directly in Power Query. So let's go to Power Query by going to Data, Get Data, and then launch Power Query Editor. And while we certainly would have the option of creating our table in Excel and then importing it into Power Query, for a simple table like this, we can actually create the table right in Power Query without involving an external data source. So to do that, at the top right, we'll click this Enter Data button. And now we can manually enter a name for our column, values to go in that column, and also the name of our table. So first we'll call our table Slicer Table. And then for our column name, we'll enter Measure. And then for the values in our column, we'll simply type out the 3 measures that we're interested in toggling among, which will be line items sold, profit, and revenue. So at this point, I think we've got everything we need for our table, so we'll click OK. And now you can see that our table has been added to the list of queries on the left. So our last step in Power Query is just to choose Close and Load, and then Close and Load To. And then, as usual, we'll only create connection and make sure our table is loaded to the data model, and then click OK. And then scrolling to the bottom of our list of queries and connections, we see our Slicer table is right there and available. So now you may be wondering where this new table we've created fits into our data model. So let's find out. Let's go to Power Pivot, Manage, and then go to our diagram view and zoom out just a bit. And now we see our Slicer table all the way over by itself on the right, not connected to any other tables. But this is actually totally okay. We actually don't need to form relationships between this and any other tables in our model, which makes sense since there are really no natural relationships to form. Our Slicer table is what's known as a disconnected table, a table with no relationship to any other tables in the data model, and it's totally fine when creating a table to be used as the basis for a slicer. So the next step then is to actually create a slicer based on this table. So we'll close out of our data model, and then with our pivot chart selected, we'll insert a slicer, and then scroll down until we find our Slicer table. And then we'll just choose the measure field from that, and we'll change our orientation of our slicer to be 3 columns, and then widen it out just a bit, and just a bit more, and then make it a bit shorter so we can stack it underneath our 2 slicers we already have. And we'll widen it out just a bit more. There we go. Okay. So now that we have our Slicer table and our slicer in place, next we need to create a measure to capture or harvest the user's selected value from this slicer. To do this, we'll need just a little bit of DAX that we haven't seen before. Now first, we need to make sure that the user has only selected one measure. Obviously, we can't return 2 measures at one time in a given cell of our pivot table or a given data point in our pivot chart. So we have to make sure our measure accounts for the possibility that our user might accidentally select more than one item. So let's go ahead and go to our Power Pivot tab and then Measures, and now we'll create a new measure that we'll assign to our Slicer table, and we'll call our measure Selected Measure. And now that first step is going to be to test whether the user's selection consists of one value or multiple values. So we'll say if, and now we'll use a new DAX function we haven't seen before, has one value, and this function takes just a single column, which in our case is obviously going to be the measure column from our slicer table. So this has one value function is going to return true if there is a single value from that column in the pivot table or pivot chart's current filter context. So if a user has selected just one item in our slicer, this has one value function will return true for that column. So in that case, we just want to return that value from the measure column of our slicer table. But remember the no naked columns rule from DAX. We can't just return the field. We need to wrap it in a function. And then only once we know it will return a single value. The whole idea is that a measure should only return a single value for any given set of coordinates in a pivot table or pivot chart. So the function we'll use to wrap the value from that measure column is the values function. So we'll type values, and again, just feed that our measure column. And now, if our user did select multiple items in the slicer, and our has one value function returned false, we'll simply return a blank. And now we'll check formula, and it looks like our measure is working, so then we'll click OK. So now that we have our measure that knows what the user selected in the slicer, we can use that to create another measure that returns a different measure value based on the user's selection. So to do that, we'll use our old friend, the switch function. So now I'll create another measure that I'll call dynamic measure, and I'll assign it to our slicer table. And now I'll use the more complex form of the switch function, whose first argument is simply the logical true. And from here, the rest of our function will simply be a series of conditions and then values we want to return if those conditions are true. So now the first condition will be if the value of our selected measure, the measure we just created that harvests that selection from the slicer, is equal to line item sold. So we'll just type selected measure equals line item sold. If so, we want to return the value of the number of line items sold measure. So for that next argument, we'll just enter our number of line items sold measure. And then the rest of our switch function will follow this exact same format. We'll say if the selected measure is revenue, then return our revenue measure. And then if our selected measure is profit, return the profit measure. And then finally, if none of those selections were true, which shouldn't happen, but we should always include a default case, we'll just return blank. So now we'll check formula, and it looks like there aren't any errors, and then we'll click OK. And now it's time to put our new dynamic measure to the test. So I'll select our chart, and then remove number of line items and profit from our values area. But then I'll add our dynamic measure from our slicer table. Now right away you may think something went catastrophically wrong because our whole chart just went blank. But if you look at our measure slicer, you see that we've by default committed the no-no of having multiple items selected. But if I select just one of these, aha! Our chart reappears and is now plotting just that measure along our 3 product categories. And then if I select a different measure, we get a different chart, but in the same location and with the ability to toggle among all of these different measures with a single click. Pretty darn cool. Now at this point, between our slicer captions and our legend, we really no longer need a chart title. It also is basically chart junk at this point, so I can go ahead and delete that. And now there's one last little bit of refactoring we can do. This on the DAX side. So you may have noticed that we created an intermediate measure called selected measure to support the dynamic measure that we're using in our pivot chart. Sounds like a pretty good candidate to refactor out with a variable. So let's first go back into our measures, and then I'll find our selected measure and edit it to grab that code. And then I'll go into our dynamic measure, and declare a variable up top, and I'll call it selected measure. And I'll simply set it equal to the code that produced our selected measure. And then I'll add a return keyword. And finally, I'll replace all these references to our selected measure with this variable instead. So I'll copy that, and then get rid of our first reference and replace it, and then our second one, and finally our third one. And then we'll check our formula once again. Looks good. And just to be safe, let's click through our different measures in our slicer. And it looks like our slicer still works fine. And now the final test will be to go ahead and get rid of that intermediate measure altogether. So we'll find our selected measure, delete it. And now it looks like our dynamic pivot chart is still working. Okay. So while, as we've seen, pivot charts are pretty darn powerful and pretty darn cool, they also have their limitations relative to standard Excel charts. We'll explore some ways to get around those, while retaining all the goodies of DAX and the data model in the next video. I'll see you then. Hey, welcome back. So in our example file here, we have a pie chart, which is commonly used for showing how different values make up parts of a whole. Now, pie charts are okay if we only want to see a breakout of a single field with a small handful of unique values. But for anything more complicated than that, things start to break down. Just for example, let's see what happens if we try to add product name to our pie chart in addition to the product category field we're already breaking out. So I'll select my chart, and then on my field list, I'll just drag in product name under product category. Whoa, that is a lot of little slices of slightly different colors. And if I drag out this corner of the chart to expand it, we see that our legend gets ever longer, and the bigger I make the chart, the more items the legend is able to show, but this is almost making things worse. What normal user could possibly make any sense of this mess? So as you can see, if we want to show proportions of profit or any other measure by product categories and then products within each product category, pie charts just won't cut it. They simply aren't equipped to handle a lot of values, much less to show hierarchical relationships like the relationship between product category and product. But one chart which can do those things effectively is called a tree map. So let's try to convert our sad little pie chart here to a tree map. So first let's contract this chart back to somewhat normal dimensions, and then I'll go up to my Design tab and choose Change Chart Type, and then down here we see Tree Map. So I'll click that, and oh no, Excel is telling us you can't create this chart type with data inside a pivot table. Please select a different chart type or copy the data outside the pivot table. So this disappointing little message is an example of the limitations of pivot charts. While you should always use pivot charts if you can, sometimes you just need something you can only get with standard Excel charts. But fortunately, there's a way to create a standard Excel chart that's still plugged in to the Excel data model. Let's see how. Now the first step is to create a pivot table with the data that will form the basis of our chart. So first I'll cancel out of this, and I'll go ahead and delete our little pie chart here, and then I'll create a pivot table with product category and product name on rows, and then our new dynamic measure on values. Now don't panic, our pivot table is returning no rows because the measure we've selected requires us to select a single value using a slicer. So right now we haven't done that yet, so our measure is returning blanks for every possible set of coordinates in our pivot table, so our pivot table doesn't have any rows. So our next step obviously is to insert a slicer. So we'll click Insert Slicer, and then we'll go down to our slicer table and add our measures field. And then just to get our pivot table to fill out a bit, we'll select one of our measures. And there we are. Now we're getting data for that particular measure in our pivot table. So I'll convert my slicer to be 3 columns wide and then resize it just a bit to make it fit our overall design just a bit better. And now we'll turn our attention back to our pivot table. So note the way our pivot table is laid out, with values from multiple different fields, that being product category and product, in the same column, column B. In addition, these values aren't repeated for every row. Instead, we only see each unique row label once. Now, while this layout may be great for making our pivot tables condensed and readable, it's not going to work as the source for a standard Excel chart. Standard Excel charts expect the data we feed them to be neatly organized in rows and columns, with no gaps in the data. So the first step then is to change the layout of our pivot table accordingly. And this is actually something we saw how to do just a few videos back. So we'll go to our Design tab, and then Report Layout, and then Show in Tabular Form. And then back under Report Layout, we'll choose Repeat All Item Labels. So now we have a column for each field in our pivot table, and we don't have any gaps in those item labels. Every row of every column in our pivot table has a value. So at this point, we, in theory, are ready to create our tree map chart. So let's highlight all the data in our pivot, and then go to Insert, and then in the Charts section of the Insert tab, I'll click this button that has a tooltip that says Insert Hierarchy Chart. So that gives me the option to choose either a tree map or a sunburst. We'll choose the tree map. And now, once again, we get slapped on the wrist by Excel. Excel says you can't create this type of chart with data inside a pivot table. So not only will Excel not allow us to create a tree map as a pivot chart, it also won't let us create a tree map just directly from the data inside a pivot table. Okay, so now we know we can't reference the pivot table directly in any way, shape, or form. Now we could just copy and paste this data out of the pivot table, but then we just have a static chart that's no longer connected to the data model and can't be manipulated or filtered by a slicer. Now obviously that's not what we want, so what's the solution? The answer is to convert our pivot table to formulas. Now that may sound kind of crazy, so the best thing to do is probably just to go ahead and do it and then show you what it looks like and how it works afterwards. So first I'll click out of this error message, and then to convert our pivot table to formulas, while we still have it selected, we'll go to our Pivot Table Analyze tab, and then in this Calculations section, we'll click the arrow next to OLAP Tools, and then choose Convert to Formulas. Now before we hit this proverbial big red button, I want to caution you that any slicers that you want to be able to manipulate your pivot table formulas with already need to be connected to your pivot table before you take this step. Once you convert your pivot table to formulas, adding a slicer that manipulates those formulas will not be easy. It's possible, but it requires a lot of knowledge about how to manipulate the formulas that we're about to see. So again, I would recommend, if you want to be able to manipulate those formulas with a slicer, make sure that slicer is connected to the pivot before we convert the pivot to formulas. Now we've already got our slicer in place, so we should be good to go. So I'll just click this Convert to Formulas button. And now we see that all of our data is still in place and unchanged, but our formatting is gone. And if I click in any of these cells, we see that instead of just a value, we have a formula called cube member with lots of scary looking arguments inside. Now keep in mind, this is just an Excel formula, and if you were incredibly knowledgeable about the cube member function, you could feasibly write this from scratch. But does this really look like something you'd want to write from scratch? Probably not. So the smart play is to get your pivot table layout exactly like you want, then connect any slicers to your pivot table that you want to be able to manipulate your formulas with, and only then convert your pivot table to formulas. So now let's see what happens to these values when I start selecting different measures in my slicer. And as you can see, the values in our dynamic measure column change every time I choose a different measure in my slicer. So these formulas are obviously responsive to a slicer in the same way that a pivot table is. And further, they're still connected to the data model. So if the underlying data in our data model changes, these values in our formulas will change as well. So in that sense, you get most of the benefits of a pivot table, but the flexibility of a formula. Now, what's an example of that flexibility, you might ask? Well, one example is you can actually move these cells containing these formulas around with absolutely no consequences. So if for whatever reason I just wanted to move these first 3 rows of my pivot table somewhere else, I can with no problem at all. So if, for example, you were creating a dynamic dashboard and you just wanted the grand total cell from this particular pivot table using all the logic in the pivot table and connected to that slicer that we set up, you could just move this one cell on the first page of your dynamic dashboard and control that single total with your slicer. And if you wanted, you could just delete the rest of these formulas. So again, these formulas are connected to the data model and they can be controlled dynamically with a slicer, but you can also move them around and delete them in the same way that you would any other cell that has an Excel formula. And to further demonstrate this flexibility, I actually don't even need this grand total for the purpose of our tree map because we don't want to include that in the chart. We're just trying to chart the individual products and their categories, not the overall number. So I can delete that, and I'll also delete the rest of this grand total row. And then I'll move these first 3 rows back into their original spot. And at this point, I think we're ready to create our tree map. So again, I'll highlight this range of cells and then go to Insert, Hierarchy Chart, and Tree Map. And look at that. While this chart could certainly benefit from being expanded just a bit because we have 25 products, which is going to make for a crowded chart no matter what layout we choose, we can now see a clear hierarchy from product category down to individual product, and then among all of the different products. We can clearly see that for the particular measure we've chosen, which appears to be line item sold, that our beach supplies product category has the biggest proportion, our surfing products category has the second biggest, and our riding supplies category has the smallest. And then within our beach supplies category, we see that straw hat appears to be the biggest seller, and then sunblock, and so on and so forth. So as you can see, tree maps are really great at not just showing proportions among different categories of our data like pie charts, they're also great at showing these hierarchical relationships. And they're much better at handling a larger number of categories that we're trying to compare. And just to prove to you that our chart is still connected to our slicer, let's change our measure. And as you can see, our whole chart changes around. Now, while beach supplies made up a bigger proportion of our line item sold measure, our surfing products make up a much bigger portion of our profits, which kind of makes sense because our surfing products are more expensive. Now, one caveat here is that charts update dynamically based on their underlying data. So if we were to delete this range of formulas that we just created, our chart would go blank. So we can't delete our formulas. However, if we're not interested in seeing this underlying data on our reporter dashboard, we can simply move our chart to a different tab. So I can select the chart and then hit Control-X to cut it, then create a new worksheet and just paste our chart in there. And then I can do the same thing with our slicer. And now we've taken one step closer to being able to create a true dynamic dashboard, and with any selection of charts that we choose. Now to that point, we can actually create another chart here, which is just a standard pivot chart, and connect it to the same slicer. So now we're using that slicer to control a conventional chart that's plugged into our data model via formulas, which is the one we see here, and then a pivot chart, which is directly connected to the data model. So let's create a pivot chart directly from our data model, and we'll put year and quarter on rows, and then we'll put our dynamic measure on values. Now right now our chart is showing it blank because we haven't connected it to our slicer. But all we have to do is select our slicer, right click, and choose Report Connections. And now we see our brand new pivot chart available to us to select as an option. So we'll check that and click OK. And now our pivot chart is connected to our slicer. And then if I choose a different metric, our pivot chart changes as we would expect. And just to spruce up our pivot chart a bit, I think I'll add product category. So I'll go under our products table, and then I'll drag in product category under our legend. And then since we're showing a time series, I think I'll convert the chart type to line. And then I'll get rid of all of these filter buttons that are cluttering up our chart. And then we'll just reposition here a little bit to get these charts and our slicer aligned in a logical way. And maybe I'll even delete the title of our tree map, since our tree map combined with our slicer makes what we're presenting pretty self-explanatory. And now as I select different measures in our slicer, both of our charts respond to our selection. And obviously, as you can imagine, you're not limited to just 2 charts. You can use this method to have a single slicer control as many charts as you want, and as we've seen, we're not just limited to the charts that are available to you as pivot charts. If you're willing to get just a little bit creative and convert your pivot tables to formulas, you can use this method to control any kind of chart. And to that point, this is just one example of a chart type that is not available to you as a pivot chart. There are several other examples of charts that cannot be created based on data in a pivot table that can be created in this way. In general, the steps to do this are: first, understand how the data has to be structured to create the chart from scratch. Then, mirror a pivot table to this structure as closely as possible. Then make sure to add any slicers you'd like to use to filter your formulas. Then convert the pivot table to formulas as we saw. And then finally, reposition and/or delete formulas as needed and build out your chart. Now there's one major caveat here, however. If the values in the fields you're using for your rows or column labels change a lot, and especially if new values are constantly being added to them, this may not be the best approach. That's because these formulas are based on the exact structure of the pivot table as it was when you converted it to formulas. If new labels are added, for example, if we add new product names or product categories, new formulas will not automatically be created in turn. Okay, so I hope in this section you've enjoyed learning how to use Microsoft Excel's business intelligence tools to build dynamic and visually appealing reporting and business intelligence solutions. Now, as much as you've learned so far, we've really only scratched the surface, but I think you know enough now to teach yourself any additional techniques you might need in any given situation to solve the problem you're trying to solve. So best of luck, and I look forward to seeing you in another course.